Okay. So anyway, we're talking about properties of logarithms, and the first one says that the log of 1 is always 0. That's because anything raised to the 0 power is always equal to 1. And that's why the log of 1 is always 0.
Is 0 to the 0 power 1?
Is 0? No, you can't have a base of 0. The base has to be bigger than or equal to bigger than 0. Okay?
Or
Can't be negative either. Can't have a negative. All right. And then the log base A of A is equal to 1, so therefore, A to the 1 is equal to A. So for instance, for example, like I was saying, so if you have log base 2 of 2, that's equal to
1.
1.
Yeah.
Because 2 to what power equals 2? 2 to the first power equals 2, right? Okay. So this is the idea of the inverse of the exponential function and the logarithmic function being inverses of each other. So if you have a base raised to a logarithm, a raised to the log base a of m, that's just equal to m, because the logarithmic function undoes the exponential function, and vice versa. We'll see some examples of this as we down here, okay? So log base a of a to the r is just equal to r, and I'll talk about those. Okay? Since logarithms are exponents, they pretty much follow the rules of exponents. So the log of a product is equal to, how come that looks like a minus sign? Does it look like a minus sign on yours?
It is a minus sign.
Oh, that should be an equal sign. That should be an equal sign. Okay? The log of, that should be an equal sign. So the log base a of m times m is equal to the log base a of m plus the log base a of n, just like exponents are that way. Okay? Same thing for division. So the log of a quotient is equal to the difference of the individual logs. Okay, and we'll do some examples where we prove it. This is a really cool property that you will use a lot. This, I don't know if you remember this, sometimes they call this rolling the log. You can take that exponent, and because of properties of logarithms, which I'm not going to go into, you can take this and put that in front, and then you get a logarithm without an exponent in there. And that thing's very, that's very useful to know. Okay? If m equals n, then the log base of the a of m equals the log base a of n. Basically, that's the rule that allows you to take the log of both sides. Okay? And same thing goes in reverse. If log base a of m is equal to log base a of n, then m must be equal to n. And this is very useful for solving logarithmic equations and stuff.
Is it called rolling the log? Is that supposed to be a pun?
Rolling the log? Kind of. Just kind of a way to remember it. Yeah. Roll the log in front. All right. So let's do some sample problems. So let's make it bigger because I can't see that. Can you see those? You can't see those here, but I can. So let's make these all a little bigger. Okay, so this says 2 to the log base 2 of, is that a pi?
Yes.
What's that got to be equal to?
Pi.
Plain old pi. Because this and this undo each other. Okay, that's just that idea that the logarithm and the exponential are inverses of each other. It's kind of like, remember, f inverse of f of x. If those are truly inverse functions of each other, those are equal to x, right? So if I take the inverse of a function, whatever I plug in there comes out to be the same thing out, okay? And so these are inverses, and that's why that works. Likewise, what would this be equal to?
Like root of 2.
Just plain old negative root of 2. Because here is the logarithmic function base 2, and I'm taking this and raising it to the negative root of 2. And also, natural log is just a logarithmic function where the base is e, so what's this equal to? This is just equal to kt, because the natural log and e undo each other. And this one is very useful. This comes up a lot in exponential growth, real life problems and so forth. Oh, I found out something very interesting today. I don't want to be politically. Let's move on. So,
Oh yeah,
I was thinking about that, Jack said, this would be a good thing to tell my students. Write each as an expression as a summation of logarithms. So if you see something like this, and you will, people get very confused by it, but it's not that bad. All you have to do is rewrite this thing as x squared plus 1 to the 1/2 power. So this is equal to this thing. When I'm facing this way, it doesn't write. So log base a of x plus, remember that rule where they log of a product, log base a of, in parentheses, x squared plus 1 raised to, now it's slowing down here. Whoa. Thing is weird.
How can you differentiate between the square root or the x root of something and x times the square root?
The little x would be up here.
Okay.
Do you need to do the
They have that technology.
square root?
Yeah, no, I need to do the 1/2 because then what I could do with that 1/2, a lot of times I'll say rewrite without any exponents. And so then you could rewrite this as log base a of x plus, and I could roll that log in front, 1/2 log base a of x squared plus 1. Like that. And that's what they want you to do for that. Questions on that? So far? Yes, sir.
For that very first part, which, like, I guess,
Log of m
did you
times
use?
log of m times n is equal to log of m plus the log of n.
Log of n plus n.
Log of m times n. This one. Yeah. Okay. Next one. Next one. So this one is real similar. You can write this using that subtraction property. So you can write it as log of natural log of x squared minus natural log of x minus 1 to the 3. And then you can take those exponents and move them in front. 2 natural log of x minus 3 natural log of x minus 1. All right. Get that? Okay. With this one, now they want you to go in reverse. So basically with this one, you want to go backwards like you were doing here. So this you could take and write as natural log of 8 raised to the 2/3 power. And there's a reason I want to do that. And then I could rewrite this. You can't really do too much with this one. You can't rewrite this as natural log of 3/4 divided by natural log of 8 because it'd have to be individual logs. So you just write this over natural log of 3 to the 4th minus 8. And then, does anyone know what 8 to the 2/3 power is?
4.
Yeah, it is 4 because it's the cube root of 8, which is 2, squared, which is 4. So this is the natural log of 4 over the natural log. 3 to the 4th is 81 minus 8. Isn't it 81? 3 to the 4th? Sure, yeah. Minus 8 gives you 72. 73. And so that's how you would do that one.
What would that be, like, raised?
What? No, it's just natural log of 4 over. Yes, sir. No, because. Oh! Sorry. Austin's right. This natural log
Mr. Leader.
needs to be out here all by itself. Okay? Equals natural log of 8 2/3 like that. Thank you. Okay? And so that's the same as the natural log of 4 over 73, which is even better, right? Thank you for racing guns. So that's how you do that, and then you can plug that in your calculator. Okay? This one looks really hard. Does this one look really hard?
Yeah, so did you ever watch Red and Stimpy?
Did I ever watch Brent? No. Is that a good show?
They have a
I have watched Breaking Bad, all of it.
You're
All of
finished?
it? Even
I'm
the
waiting.
season?
I'm waiting for season 6.
Oh, you finished?
Yeah.
Doesn't it end crazy?
Okay. Shh. Anyway, I gotta get through this. So this you can write as log base A of 9x times x squared plus 1 over 5. That's it. Did you follow what I did?
No.
This and this are plus, right? So you can write that as a product. This is plus again, so you could write that as a product. And this again is minus, so you could write that as a quotient, right? So that's how you can rewrite that. And then you just leave it like that. You don't need to multiply it out unless you want to. Okay? Then we got to do some other ones. They get more complicated. This is very important. The change of base formula, which you might know or may not know, is because properties of logarithms. So someone was asking me, use the change of base formula to find log base 2 of 7. Because on your calculator, you don't have a log base 2 button. All you have is a log base 10 button and a log base E button, which is natural log. So what I could do is rewrite this as, using these formulas, I could rewrite this either as log base 7 over, log base 10 of 7 over log base 10 of 2, or natural log of 7 over natural log of 2. And then all you have to do is plug that into your calculator and you'll get an answer. Okay? And Linda got it for us, and he said that that is 2. Oh, you can do base 2 on your calculator?
Yeah.
If you go math and then to the bottom.
Oh, that's cheating.
Yeah, right.
Okay. Yeah, well,
Wait, how does
if you had just a scientific calculator, you can't, but you do have to know the change of base formula. What?
how does log 7 over 2, log of 7 over log of 7 over natural log of 7 over natural log of
Because
2?
what this formula says is it
Oh, it's a
doesn't
ratio.
matter. Yeah, it doesn't matter what the base is, it's the ratio. Okay? And then, so you could use that to graph this, okay? Because if I wanted to graph this function right here, I could rewrite this as y equals log base x over log base 2, which in your calculator, you can just plug that into your calculator. And if I did that, let's just do that. And you can either use natural log or base 10 log, it doesn't matter. If I were to do this on my calculator, or I can never see this, where's the quit button? Is this quit?
Yeah.
Quit, clear. So if I want to plug this into my calculator, I go y equals, and so log of x divided by log of 2, and if I hit graph, I should get a logarithmic function, but my window is probably all messed up. So I'm just going to hit a zoom 6, which is just a normal viewing window, and there you go. Good. And so then you should get, and then you can answer various questions. Okay, your homework isn't that long. I do have scheduled, I do have scheduled another quiz on Log Day.
No, that's tomorrow.
That's tomorrow. And it would cover, I'll go over this homework first, okay? And there's just a couple questions on this homework on it. And then there's stuff that we went over today on it, okay? And I will try to have that quiz
Yeah.
from last Friday graded by tomorrow.
Okay.